Okay, hello, Assalamualaikum. My name is Muhammad Khairul from DPE 3B. My metric number is 33DPE 19F1056. Okay, today I'm gonna do an explanation about heat exchangers for heat transfer, subject heat transfer in this video. Hope you enjoy. First, we're gonna talk about heat exchangers, the basic concept of working principle of heat exchangers. Heat exchanger facilitates heat transfer from one medium to another, often these media are two processed fluid streams such as oil, water, steam, gas, air, and etc. In general, one fluid has to be significantly hotter than the other, so we have a hot and a cold fluid, and a heat exchanger enable the heat to flow from hot fluid to cold through a metallic wall. Heat exchanger channels the flow of hot and cold streams through passages separated from each other by metal surface. Thanks to the high heat conductivity of the metal, heat flows from hot stream to the cold one, so the hot fluid exits the heat exchanger a little colder and cold stream goes out a little hotter. That is why heat exchangers are widely used for heat up or cooling down a fluid stream in the processing plant, because we want the product of that come out of the heat exchanger is exactly as what we want. And then I will talk about basic concept, log mean temperature difference method, LMTD. The formula is delta T M equal to delta T1 minus delta T2 divided by ln delta T1 over delta T2. The log temperature difference LMTD in the short form is used to determine the temperature driving force for heat transfer flow system. Most notably in heat exchanger, the LMTD is a logarithmic average of the temperature difference between the hot and cold streams at each other end of the heat exchanger. The larger the LMTD, the more heat is transferred. If the LMTD is low, then there are less heat is transferred. The use of LMTD arises straightforwardly from the analysis of a heat exchanger with a constant flow rate and fluid thermal properties. A generic heat transfer has two sides, A and B, at which the hot and the cold streams enter or exit. Okay, and then I've decided to choose to talk about shell and tube heat exchangers. Okay, now I'm gonna talk about the basic principle of working of the shell and tube heat exchangers. Fundamentally, shell and tube exchanger is to pass a hot fluid through a cold fluid without mixing them, so that only their heat is transferred. It has it has two inlets and two outlets, where each fluid starts at the respective inlet and exit the device at their outlet. The tube side flow passes through the tube bundle secured by metal plates known as tube sheet or tube plates, and exit the tube outlet. Similarly, the shell side flow start at the shell inlet, passes over these tubes and exit at the shell outlet. The headers on either side of tube bundle create reservoir for the tube side flow and can be split into section according to heat exchanger type. according to specific heat exchanger type. Each tube contains an insert known as tubulator, which causes turbulent flow through the tubes and prevents sediment depositing or falling, as well as increases the exchanger's heat transfer capacity. Designers also cause turbulence in the shell with barriers known as baffles, which maximize the amount of thermal mixing that occurs between the shell side fluid and the coolant pipes. The shell side fluid must work in its way around these baffles, which causes the flow to repeatedly pass over the tube bundle, thus transferring energy and exiting the heat transfer at a lower temperature. Certain shell and tube exchanger use different baffle shapes to maximize heat transfer, and some use none at all. The shell and tube exchangers can be single or two-phase. A single-phase heat exchanger keeps the fluid phase constant throughout the process. Example as liquid water enters, liquid water leaves. While a two-phase exchanger will cause a phase change during heat transfer process. Example, steam enters and liquid water leaves. They can also be a single pass or multi-pass, which simply describes how many tubes the tube side or shell side flows pass through the device. Okay, the construction of the heat exchanger is basically as what we can always see if a diagram. It's a shell. It has a shell and it has a tube in it, like this. That is the construction for the shell and tube. There's a tube outlet, shell inlet, baffles, like I said just now, rear and header, front and header, tubes, shell outlet, tube inlet. The shell and tube heat exchangers component is basically, we have to know that if the name is shell and tube, then it means it has shell and it has tubes. Also, it has pass partition to separate, stationary head channel, support saddles, baffles, as I talk about in the working principle, floating head cover, shell cover, floating tube sheet, tie rods and spacer. Yes, also tube support baffle and etc. The advantages of shell and tube heat exchanger: they can be designed and manufactured to bear very high pressure. This is the advantages. They are extremely flexible and steady design. They can be designed and manufactured to bear very high and very low temperature. They are resistant to thermal shocks and they have no dimension limit. They can be used in all applications, as we can find if we need to use an heat exchangers. We can use also at home. Pressure loss is at a minimum and can be maintained at a minimum in line with process purpose. They can easily be disassembled and assembled back for maintenance, repair and cleaning. Easy maintenance and repair. The pipe diameter, pipe number, pipe length, pipe pitch and pipe arrangement can be altered. So the design of the tube heat exchanger are quite flexible, I can say, because we can adjust it to our to what we like to see it. And the disadvantages for heat exchanger: the heat transfer efficiency is less compared to other heat exchangers. Cleaning and maintaining is a bit difficult since a tube cooler requires enough clearance at one end to remove the tube nest. Capacity of the tube cooler cannot be increased because it follows the tube size and require more space in comparison to other heat exchangers and coolers. My reference is from I will talk the reference that I take from is thomasnet.com from Google, Akin Industrial, and marineengineeringonline.com. That's it from me for the topic exchanger for this assignment. And I have talked about the shell and tube exchangers, working principle, construction, component, advantages and disadvantages. Thank you very much.